Well, hello guys, we're back. It's been a little while. We've had a few little problems with my car and stuff, so I was working on that and a few other things. But anyway, we're back and ready to go. We're going to do about 3 problems I'm going to show you, and then I'm going to leave you with a problem that you can kind of try to guess. Actually, this video is going to be a little bit of bonus because there's actually 2 problems I'll let you kind of think about and ponder about, and you can write what you think is going on. But they should be interesting. Troubleshooting. Now, I'm going to take this more or less from the standpoint of a restorer point of view. You restore a radio, you go through, you do your standard procedure of replacing caps and maybe checking resistors and placing those, and maybe tubes and whatever, and clean things up, and you may have some bad wiring you got to replace, whatever. And now you're at the point of first power up. The very first rule that you should always remember in troubleshooting, at least in my opinion, and other people may have different ways of doing things and they may have different rules, but the very first rule in my opinion should be, if you have a problem, check the obvious first. Now, the reason I say that is this is a problem that I've had happen before, probably more times than I want to admit, and it's a problem that I've seen videos other people have. And let's say you got the radio all done, you're ready for your first power up. You've got maybe a isolation transformer, because like this radio, there's no transformer, so you want to use an isolation transformer on it. And I'll be going through a variac that has an amp meter and a voltage gauge on it. Some of you might use a dim bulb tester, but the point is, you start things up, you turn the radio on, your isolation transformer, you turn it on, and you start cranking the variac up. As you crank the variac up, you're looking at the radio, you're probably paying attention to the dial lamp, and you're watching the meters, and the voltage is going up, but no current's coming on the amp meter, and now the dial light's not working. It's not showing anything. You're getting up there, maybe you're getting up 60, 70, 80 volts to it, and by 80 volts you should get something going through that rectifier. You should be getting some voltage on your meter that you got hooked in there checking B+. Your dial lamp should be coming on. You should be reading some current, but nothing is happening. You sit there and you ponder this, maybe you crank it up some more, and you finally say, well, there's something wrong. Well, the very first thing, always check the obvious. And I say that, again, because I've had it happen to me. And, with a little understanding, it's probably late at night, if you're like most of us, that you've gotten to this point. Maybe you've worked on this radio for several different days and getting it to this point, and maybe this is the day you're going to be doing your first power up. You had a few more things to tidy up, maybe a couple extra capacitors put in, or whatever, and now it's getting late, you're tired, you worked all day and everything, but you're also a little excited. Man, I want to see this thing work, I want to hear it. It may not be quite perfect, I may still need to do alignment, but be nice, it makes some noise. And so you try to power it up and nothing happens. Well, it may be because it's not plugged in. So always check the obvious. Believe me, I have done this. more times than I want to admit. You know, it happens. You forget to plug something in. You know, and say it is plugged in, and you're still not getting anything. Well, the next obvious thing is maybe the power switch. Check it. Make sure it's okay. It may, you know, be open. You might have forgot to test it. Who knows? Whatever reasons. And one quick thing you can use is, you know, just use a you know, alligator clip or something like this, and just short across, just to rule it out. You know, all you gotta do is connect the two leads in here to rule it out. Alright, there's various other reasons for no power up. Maybe you're not getting power to your equipment. You never know that you're trying to power it up with. But always look for obvious things. Maybe even some loose connections. Maybe you didn't get the power cord soldered in good, or maybe you forgot to solder it or something. But look for the obvious stuff first before you do anything else. Now, suppose it starts powering up, and yeah, you can see the meter. So we're going to flip it on here, and right off the bat, this was actually for somebody who's having troubles with the radio. I've watched their videos, but it turns out I went back over the videos before I ever done this, and this, I don't think this is their problem, but just in case you run into this problem, I'm going to show you what we're going to get here. Make sure I got the radio turned on, and we're going to start powering it up. Now we're getting some dial light. It's pretty dim. We're going to keep cranking it up here. We're going to bring her up around 70 or 80 volts. Now things is going to start happening, and we got some dial lamp. It's not real bright. I've got about 80 volts on it, but I only got about 5, 10, 20 millivolts. I'm negative now. I'm going negative quickly, up, 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 and that's about as far as I want to take it. Mainly because I want to blow up capacitors. What is actually wrong is I wired this thing up to different switches so I could produce different problems in it. Well, one way I wired this thing for one particular switch is the rectifier tube down here. I wired it up so that when I flip the switch, it's in backwards. You know, you might run into this problem if you've got a radio that you know, had a bunch of bad wiring, and you end up wiring it up, and so you manage to get the rectifier reversed. And basically, if we look on the schematic, it's pin 5 and 8, and I switch those, and you know, that can happen. And what will happen is now the rectifier is still working, but it's going to send out the voltage is going to be backwards or in reverse. In other words, on my B plus is going to be negative voltage on it. So you want to make sure, if you see this, if you start getting a bunch of negative voltage coming on, shut her off, get her powered down, and check your wiring to that rectifier. Sometimes other potentials can be if you get a capacitor turned in backwards, or all your filter caps can sometimes cause this problem too. Right now it's discharging. Who I actually did this for, I think he knows, but I actually got looking at his videos again, and what it turns out I think is wrong is on one of his videos he showed up one of the tubes, the 7B7 tube in his radio, and he had the capacitors. See, the capacitors are connected the negative leads are connected to pins 3 and pin 4 on the 7B7. Well, pin 4 is the suppressor grid, and that should go to ground. So it needs to be connected to pin 5, which is a ground point on the tube. And it's already got one capacitor hooked to it, and that's fine. Negative lead's hooked to it, but it needs to move pin 3 lead, the pin 3 capacitor that's hooked to pin 3, it needs to be moved to pin 4 also. Because pin 3 is a screen grid, which should be having about 55 volts on it. And this would explain why he was getting a negative voltage on the plate, because pin 4 was going absolutely nothing, so it was fully open. There was no ground, no completed circuit. The capacitor hooked to it, filter cap, on its positive lead would have about 120 volts coming right out the rectifier. And tubes are high impedance on any of the pins. So as far as the tube was concerned, on that suppressor grid became 120 volts there. The plate normally runs around 90 volts. So you got a difference there of 30 volts that the plate is actually negative in respect to the suppressor grid. So you end up with a reversed flow of electricity. In other words, we're taking electrons away from the plate, pulling them back to that suppressor grid, and that what he ended up is getting a negative reading on the voltmeter they had hooked there. So Bret, go ahead, move pin 3, that electrolytic negative lead, to pin 4 of the 7B7. Make sure you connect pin 4 also to pin 5. That'll give it ground, and also give ground on downward from there, because that's also, pin 4 is connected as a ground point going to your audio output tube. So get pin 5 and pin 4 connected. Get pin 3, the capacitor hooked to it, to pin 4. That should help out at least with your voltages. Now beyond there, you'll have to do further testing to make sure everything else is working right on the radio. But try that and go ahead and make a video of it, and we'll see where we're at. Now moving on to our next little problem. Now I'm going to go ahead and bring this thing on up. I've ran this thing several times, so yeah, about right there, should be close enough. And if you guys want to follow along, on Nostalgia Air, they have the schematic. It's not exactly the same one, because Riders for some reason does not even have this radio in theirs, but it's darn close. You look up the Philco 48200 and 200i on Nostalgia Air, and you can download the schematic. There are several pages actually, and the few minor differences is this runs a 50A5 output tube, where the 48200, this is a 206, runs a 50L6 output tube. They're actually almost identical tubes. Really the biggest difference is I think the 50L6 is a regular octal tube, and the pin layout's just slightly different. But otherwise, electrically, the characteristics are the same tube. And then the other difference is this runs a 35Z5 rectifier, where on the 200 it's running a 35Y4 The minor differences in that is internal voltage drop across the tubes is a little different, so the voltages are just slightly different. That's on there, they're close enough, it doesn't matter. Basically what I did here pretty much is it won't make any difference. You won't be getting any readings what they'll be giving you or anything that'll be like real close, but just a little bit off. Basically all I'm doing is breaking circuits. So anyway, our next little problem is we'll turn the radio on, get it start warming up with no problem in it right yet, and then we'll create a problem and let you hear it when we create the problem. Now there's hum in this radio, and it's there because of obvious reasons. All this extra wiring and stuff is not real conducive for good wire management or good wire dressing. But I've got a signal generator running into it, and that's what you're hearing right now. And we're going to create a problem. I lost it. You notice the voltage dropped down. I lost voltage on a point, and that point is right here, which is pin 3, and that's the 14A7, and pin 3 of the 14A7 is, let's see if I can get this in here. This is the 14A7 right here. Pin 3 is my screen grid. I lost voltage on that. As you notice, I also lost my tone. Now where does that voltage come from? Well, we follow it back and come down. Now it's also supplying, and that's part of the reason why I lost some sound, because it supplies voltage back here to pin 5 on the 7/8 tube, which is our mixer tube. Goes through a 27K resistor, our dropping resistor, and then that follows back across and down to our B plus right here. Now the reason why we lost sound is we've effectively killed our mixer tube. It needs that voltage there to operate properly. So we effectively shut it down. Now what I did was, and what actually how I broke it was, I just broke the resistor that goes. It's this resistor right here, and that's the one I broke. Or not that one, I'm sorry, I made a mistake. It's this one down here, the 27K, and I hope you can see that. That's the guy that we broke. Now if I flip it back on, we have it, and we lose it. So if you see, the second thing you always do when you're troubleshooting, after you check the obvious, is always check voltages. That's the most primary thing to do. And I would do this almost live. I mean, basically what I've got is I put test clip leads in. I would go through it, but with the mess I've got here with the wiring and stuff, it's real difficult to get in here. But this is the mixer, this is the IF. It was easier to clip here than down here where the resistor actually connects. This resistor normally would connect over in this area over here where B plus is picked up at, and you would, in normal circumstances, you would start checking your voltages throughout the radio. Make sure that they're all there. Your voltages will be marked either on the schematic, like on the tubes, or they'll be marked on a table, and they'll tell you, the 7A8, the 14A7, and so forth. And they'll give you pin 1, 2, 3, and 4 all the way through. And you just check all those voltages. Now, these voltages are generally, they'll give you some instructions down here at the bottom about the voltages. Basically what it says is, which we're not actually doing, is use a DC voltage measurements are at 20,000 ohms per volt. And if it's AC measurements, is 1,000 ohms per volt, VTVM. Well, we're not exactly doing that, but some of the other instructions on there is socket connections are shown as bottom views. In other words, so that you'll be working down here in the bottom, so all the connections on the schematic is shown as such as you would see in the bottom of the radio. They'll tell you that the measured values are from socket pin to common negative. This is not technically a hot chassis radio, meaning that this is B minus right here, but it flows all through on a wire going through the radio, but the chassis itself is not actually DC negative. Line voltage maintained at 117. We're at 116, roughly 116 and a half. And then they'll tell you just the normal tolerances of component values makes possible of a variation of plus minus 10% in voltage and resistance readings. Volume control at maximum, no signal applied. Well, you actually got a signal applied. What they talk about the resistance readings is the nice thing about SAMs. Also, they give you a resistance reading. This is done no power to the radio, and you actually connect, unless otherwise stated, you will connect an ohm meter to the pins of each tube to the common negative and check the resistances with no power to the radio, obviously. And it's another way of checking things to see and maybe possibly find potential problems. Now, oh wow, this is getting long. On to the next problem, which we'll probably go through fairly quickly. We'll go ahead and flip our switch back on. And our next problem is going to be your problem to figure out. And so let's see here, which one do I want to do? I did A, D, B. Okay, we'll do, I think we'll do this one. Lost everything, no sound. Showing roughly negative 4 volts. This is connected right here to this pin here, which is pin 2 of the audio output tube. Pin 2 on the schematic. It's this pin here. I have no voltage. Well, I actually got like a negative 4.85 volts. Of course, naturally, if I don't have any plate voltage, I don't have no sound. So what I want you to determine is the possible causes and why that would not have voltage there. That's problem number 1. The second problem, this is a series wired radio. Has no transformer, so they hook all the tubes in series. Just you've seen these, but you know, you go through the rectifier and you go through each one of the tubes back to ground, which comes back around to the plug. Alright, now you have a 35Z5, a 50A5, a 7A8, 14A7, a 14B6. This is 35 volt tube, this is a 50 volt tube. A 7A8 is 6.3 volts, just your standard 6 volt tube. These two 14 volt tubes, or 14 tubes, are actually 12.6 volts on the filaments, or heaters. This one here, the one that was in it had an open heater, and I didn't have one. I ordered one, but I didn't have one available, so I had to order one to finish this radio up eventually. So I put in, actually I put in a 7A7 in there instead of a 14A7. A 7A7, instead of being 12.6, it's 6.3 volts. Now it is doing just fine. It's operating just fine. And if we look at the filament, and I don't know if we can get a good shot of it, the filament looks fine. It don't look any brighter than that one there. I hope you can see it. Maybe right there. Right there. But what I want you to tell me is why I can put a 6.3 volt tube in place of a 12.6 volt tube, why it doesn't burn out. It should obviously burn out. I'm trying to pump more voltage through it. So you figure that one out and you can let me know. We're going to have to end it now, so we're about out of time. There's two problems for you, and thanks for watching, thanks for your comments, and we'll see you on the next one.